Okay, here's our next example for the subnetting, just to make sure that you really got the idea and that it's solidified. If you haven't done the previous ones, please make sure you go and check those out before you dive straight into this one. These videos are designed to be watched in sequence and in series. So if you haven't seen any of the previous ones, please take the time to go and look at those now. If you are on track and you're currently in the right sequence, here it is. Let's have a look at our next example. So, I promised in the last video that it was going to be a little bit harder than what we've seen so far. So, let's throw you in the deep end a little bit. So, I've got a network. Again, the first value doesn't really matter, right? I mean, it really doesn't matter what it is that I start you off with. I'll keep it with a /24 for now. So, what we've got is there's the name of our pizza, right? 10.10.10.0/24. Now, whatever this might be, right? It's a carnivore pizza now, right? That's what we've now got. So it's just pure meat. Love it. So now what we've got is a network that we've got a provision for. We've got a router with a segment that has a WAN link that goes to a router with a segment that has another WAN link that has a router with another segment. Told you it wouldn't be so easy this time. So, with this discussion, we're going to say that this requires 30 IP addresses in this segment over here. This segment over here, I'm going to say, only needs, let's think about this. Let's make this guy 14, and let's make this guy 10. All right, that'll do. So there it is. There's your synopsis. And then don't forget, WAN links always require 2, right? There's always 2 IP addresses on a WAN link, this side and that side, this side and that side. So those will be your IP addresses. So 2 for each of those WAN links. There's 2 WAN links involved. Again, I challenge you to try and do this on your own. Right, so there's your example. Grab pen and paper. See if you can get this done right. Pause the video now and go and try and figure out yourself. And once you're done, kick back in the video and I'll show you the solution. So hopefully that went well for you, right? If you've just done it, hopefully you've given it a chance and hopefully you aced it. If not, let's have a look at the solution. And let's see where you went wrong if you didn't get it right. So again, our binary table, we always need it. Remember again, we're dealing with pizza, right? That's what we're looking at. We've got a pizza pie. And we've got to slice and dice this up to feed quite a few more people this time. Right now we've got 3 major networks plus 2 WANs. So we've got 5 separate networks that need to be fed, 5 individuals. Their hungriness varies from 30 to 14 to 10 to 2 and 2. And you'll notice I did that in descending order from biggest to smallest. Right? Always when it comes to doing any of this, you have to start with the biggest network slice. So again, let's go through the motions. 30. In order to have 30 bits, I need this many bits to represent the number 30. Why? That many bits will give me 32. Don't forget, -2 gives me exactly 30. That's awesome. Perfect. Draw the line. Split it down. Right. Once you split it down, what have we got? Well, let's draw it with a different color, otherwise it gets really dull. So, what have we got now? We have 0, 0, 0. 0, 0, 1, 0, 1, 0, 0, 1, 1, etc., 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 1, 1, 1. You're getting the idea now. So we've taken our pizza, we chopped it up. It ended up being 8 slices. First one over here becomes 0, 0, 0. Congratulations. This guy becomes 10.10.10. That is still equal to nothing. .0/27. Why /27? It was /24, and you've now used 3 more bits. Remember, this is now all part of the network portion, and this section over here is now all part of the host portion. All right, so 3 more bits have been used for the network portion, so it was /24, it's now /27. Okay, brilliant. This network, done, catered for, fed, happy. Now we've got to go for the next biggest one, which is 14. Now from the 14... let me just change the color of our pen over here. From 14, it's a little bit of a different scenario because for 14, I only need that many bits, which gives me 16 minus 2 is 14 exactly. Cut the pizza up again. 0, 0, 1 is this slice, right? That's this slice over here. The trick with this slice is the user doesn't want, or the network doesn't want, the whole slice. They're not that hungry. They only want half of it. So I need to cut it. And there's that cut. 0, 0, 1, 0, 0, 0, 1, 1. Those are the two sub-slices. So this slice would be 0, 0, 1, 0, and this slice would be 0, 0, 1, 1. That being the case, this network here of the 14 could then use the IP addresses of 10.10.10.0010. What does that equal to? 0 is still 0, 0 is still 0. That is equal to 32, and we'll use the first one here, which is 0. So 32 is the final result. It was a /24. We stole 3 bits that made it 27. We've stolen another bit that makes it a /28. Beautiful. What do we do with the 10 network? Change color first. What have I not used? There we go. Purple. So, 10. 10 actually doesn't move this line. We still require these bits in order to use the 10. So the good news is this network here is still vacant. Right, it hasn't been used yet. So although this one was consumed, right, this slice over here, this slice is still free. Right, it's uneaten. So it's now 0, 0, 1, which is 32, plus 16 is equal to 48. So this IP address becomes 10.10.10.48 / still 28. You haven't moved the line. Right, it's still where it was before. And that is now the 10 network catered for, right? Because you needed 10 IP addresses. Voila! So even though we had 3 networks in this case, it hasn't changed the synopsis, right? Everything carries on the same way. We still divide the same way. We still slice and dice the pizza the same way. So nothing really drastically actually changes. Now, finally, the last and final port of call on this one. What about our WAN links? Well, that hasn't really changed. We're still going to use the same structure. We're going to use the last slice of pizza, right? We always use the last one for the WANs. So now within that, we just need to slice this up even further. And if you remember, I always said your WANs are generally going to be a /30, right? So 2 bits on that side. 1, 1, 1, 0, 0, 0, 1, 1, 1, 0, 0, 1, 1, 1, 1, 0, 1, 0, and so to progress. Now I only need 2 because I've only got 2 WAN links. So I'm going to use 1, 1, 1, 0, 0, 0. Right? That is going to be the first network. So link those two together. 128 plus 64 plus 32 plus nothing, nothing, nothing is 224. So the IP address for this WAN link here will be 10.10.10.224/30. The second WAN link gets the very next one in line, which is 224 plus an extra number, plus 4, right, which is 228. So the IP address for these WAN links would be 10.10.10.228/30. And you're good to go. Now, I want to bring something to your attention here about these WANs. These WANs actually create 4 IP addresses, right? So the IP address, if we look at the 224 for a second, right, 224 was this one. 1, 1, 1, 0, 0, 0. But do you guys agree that there are 2 bits over here? Right? There are 2 bits here that I can manipulate. And these 2 bits could be 0, 0, 0, 1, 1, 0, 1, 1. So 4 possible combinations. But the rule was always that we cannot use the first, because that's the name of the network. And we cannot use the last, because that's the broadcast address, which means we've got the 2 in between. Now the 2 IP addresses in between here, in this case here for the 224, this guy could have IP address .225, and this interface would have .226. 224 cannot be used because it is the name of the network, and 227 would be the broadcast address. Similarly, 228 cannot be used, that is the name of the network, but 229 would be the first usable IP address, and 230 would be the next usable IP address for that interface. Now, a question I often get in classes is, hey Jay, how do you know which side to give which IP address to? It doesn't matter. So 229, 230, flip them around, it doesn't matter. As long as it's 229 and 230, and in this case 225 and 226, it doesn't matter which side of the WAN link gets which IP address, right? That matters not at all. So hopefully these examples have helped you with your subnetting. Hopefully you got the idea behind it. I'm actually going to call it quits at this point in terms of examples, unless I see some crazy comments inside the videos. If a lot of people are still struggling or there's a lot of questions around it, I will happily make some more videos and more demonstrations and show you other ways to achieve this and get it done. But hopefully this has solidified and nailed the idea of subnetting for you. And of course, you've got multiple videos here that you can go back and watch multiple times until you get it, right? Until you click and you have that eureka moment about how to do the subnetting. So with that said, that is bringing us to the end of subnetting. And of course, what we want to have a look at next is how to supernet. Supernet is doing all of this backwards, where we start with many. We want to reduce them to few. Whereas this was always taking a singular, making it many. We now want to do it the other way around. So it's actually pretty simple to do it that way. That will be our next little topic here for IPv4 addresses. Again, please leave any questions or queries inside the comments. If this helped you or you got the eureka moment, let us know inside the comments as well. Hit like, hit the subscribe button, and have a great day.